So today we'll be looking at elementary identities. These elementary identities will help us to solve problems in simplification of algebraic expression. So the first identity here is difference of 2 squared. That's a squared minus b squared. So we have a plus b, a minus b. So that's the first identity. So the second one is addition of 2 squared. A squared plus b squared is equal to a plus b squared minus 2ab. So though you can write it as a minus b squared plus 2ab. So we have two expression for this. So the third one is expansion of perfect squares. So if you have a plus b all squared, to expand this is a squared 2 times a times b. As remember, it's plus or minus because of the sign here. So 2ab, and finally plus b squared. So we call this second identity. This is third identity. So again, there is one important identity. If you have a raised to power n, b plus, okay, let's start with plus. So the first factor of this is a plus b. If it's minus, you write minus. So we have the second bracket. A will start decreasing from n minus 1 since we've written 1 here. So it will go down by 1. So if it's plus, remember what is here is plus. So it will keep on alternating in sign. This is plus minus a n minus 2. B will increase by 1 plus a n minus 3 b. So that's how it will go till we'll get to a raised to power 0. A will decrease to 0, while b will increase to n minus 1. So again, if it's minus, this is minus, this will always be constant. It will be constant plus all true. So that's it. If it's minus, plus, all constant, it's always plus, except the first bracket, which is minus. The second bracket is always. So with that, we can get an identity for addition of 2 cubes, like a raised to power 3 plus b raised to power 3. With the help of this, n is 3, so we have a plus b. So 3 minus 1 is 2. B raised to power 0 is 1, so no need. Minus a3 minus 2 is 1. B raised to power, so ab plus. If you notice, a has decreased to 0 now because 3 minus 3 is 0. So a raised to power 0, which is 1. So we're left with b raised to power 2. But if you could remember, so let's call this identity. This is identity 4 and 5. This is 4 and this is 5. So we can call this identity 6. But if you remember, addition of 2 squared, because we have addition of 2 squared here. But if you remember, I'm using this. So using addition of 2 squared identity, that's a plus b. Remember, I told you it has 2 answers, either a plus b all squared minus 2ab, or a minus b all squared plus 2ab. So I will substitute this with a squared plus b squared. So we are still on addition of 2 cubes. So we have a plus b. Why the second bracket? I'm using this first one. A squared plus b squared is now a plus b all squared minus 2ab. That's for a squared plus b squared minus ab. Do you get the logic? I replace a squared plus b squared with a plus b all squared minus 2ab. Finally, minus ab. So what we have here is now a plus b all squared minus 2 minus 1 is minus 3, so minus 3ab. So we'll call it under this, very important, call it 7, that a cube plus b cube is also this. So if you don't use this first, the 6th one, use the 7th one. So for the second, we've gotten for the first one by substituting this. Let's substitute for this. So we have this. Remember, using the second one, which is now that I'm replacing a squared plus b squared with a minus b squared plus 2ab. Finally, minus ab. Do you get what I'm doing? Remember, I told you we'll replace a squared plus b squared with we replace a squared plus b squared with this. So finally, minus ab. So that's what I did. So we have a plus b is a minus b all squared. 2 minus 1 is 1, so plus ab. So we'll call this equation 8. So a cube. I said that a cube plus b cube has 3 formulas. The first one is a plus b, a squared minus ab plus b squared. That's the first one. The second one, we have a plus b all squared minus 3ab. So that's the second one. And finally, a plus b a minus b all squared plus ab. So that's the three identity for cube. So let's go to the difference of two cubes. So the 8 identities, difference of 2 cubes. So again, using the formula for the nth, which is now a minus b, we have a squared plus, it's always positive, that the sign is all true, b squared. Again, from addition of 2 square, a square plus b square, we know that is a plus b all squared minus 2ab, or a minus b all squared so we have plus 2ab. So that's it for the, so we replace is a minus b. So I now replace a squared plus b squared with the first one, which is a plus b squared minus 2ab. Before I write a plus b, that is, I replace a squared plus b squared with this. So we'll go down to this a plus b all squared minus 2 plus 1 is minus 1, so minus ab. So we'll call this, remember the other one is 8, this is 9, and this is 10. So let's get the 11th one. So again, we can replace a squared. Remember, this is a minus b. We can still replace a squared plus b squared with a minus b all squared plus 2ab before the ab. So I'm replace this. I replace a squared plus b squared in. I replace a squared plus b squared with this one. So we now have a minus b all squared. This is plus 3ab. So this is the 11th equation. So with that, you see that a cube, difference of 2 cube, has 3 formulas. The first one is this: a squared plus ab plus b squared. The second one is a minus b is a plus b squared minus ab. That's the second one. And finally, a minus b squared plus 3ab. So that's the 3 formula for difference of 2 cubes. So again, another identity, if you have a plus b plus c all squared, it's always a squared plus b squared plus c squared plus 2 bracket ab plus bc plus ac. This is another important identity. So the other one is also, if you have a plus b plus c raised to power 3. We have a cube plus b cube plus c cube plus 3 brackets a plus b. That's a plus b. The other one is b plus c. Finally, a plus c. So that's the identity for this. So if you have a trinomial raised to power of 3, so the other one is now, if you have a plus b raised to power 3, is always a raised to power 3 plus b raised to power 3 plus 3ab a plus b. So that's the identity. With this identity, we can simplify algebraic expression. We use all these identities. So let's now go over to real exam questions where we apply all these identities.